Howdy, folks. Welcome back. Welcome back. Welcome back. We're going to get right into it. There's 2 lessons in this video. It's going to take a while to go through, but let's get started. So, in review, from before we left, let's talk about 5-number summary and how we can create a box and whisker plot out of the deal. So we've got 5 numbers. The minimum number is 0, maximum is 250, medium is 100. You've got quartile 1, which is 50, and quartile 3, which is 160. Recall, each one of those numbers separates the data into 4 quarters. You hear some noise in the background. I'm at the local coffee shop out here where I live, and that's the baristas on their breaks. So I'm going to create the box and whisker plot. Here you go. As you can see, your minimum starts right here, 0. That's the left whisker. And then at 50, we've got quartile 1, which is the first start of the box. And the median is 100. That's the middle of the box. Quartile 3 is 160, which is the end of the box. And then the maximum is 250, which is the other side whisker. All right, so let's get into the next lesson. Good things. Hope you guys had a great holidays. Had a good time. Been working on my new house. It's been a pain in the butt, but hey, it is what it is. All right, let's get going. Unit 3, survey design. This is the first lesson of the new year, the new semester. Survey design is the 8th lesson in Unit 3. So let's look at this. School uniform should not be required. Agree or disagree? Standardized dress can promote productive school environment. Agree or disagree? Both of these questions show design of a survey can influence the results. You can see on the one on the left, if you're asked that question, you're going to think, hey, you know what? I probably don't think that's a good idea. Should not be required. You're giving them an ultimatum. The other one says standard dress can promote a productive school environment. What you're asking there is, hey, is wearing school uniforms actually good to promote an environment that is productive? So that kind of puts a positive spin on it. Yeah, both of these will influence the results. Now, questions for a survey should be designed in a neutral fashion that allows accurate recording of the opinions and facts of those people that are participating in the survey. For example, uniform question could be worded like this: I'm in favor of school uniforms for high school students. That doesn't tell them that they need to be required or they don't need to be required. It doesn't tell them that they can promote a productive school environment. It doesn't do any of that. It just says, I'm in favor of school uniforms for high school students. And then it gives them a scale in which to determine their level of whether they agree or they disagree. So this is an example of a closed question, the ones above, because the participants are limited to the response choices that are given. Closed questions are easier, usually cheaper to analyze. Sometimes the computer does much of the work. Open questions allow participants to give more detailed responses. This approach requires follow-up analysis that is more labor-intensive and a lot more expensive. All right? So, a closed question. Do you like mathematics? Yes or no? An open question. What is your opinion of statistics and mathematics? And then you're just given a blank. Okay? So, move on to the next slide. Reword the school uniform question in an open question format. Okay, describe your opinions about school uniforms for high school students and give them an open response. That is an open question. Free response is when you can write a sentence and give your free opinions about it. It's wide open. All right. Because the design of a survey is so important for capturing the information needed accurately, pilot surveys are often conducted. Pilot survey is defined as a small number of people that are surveyed, and then they're analyzed to look for the following. They look for ambiguity in questions. In other words, do they not really make sense? Are they too confusing? They're not created in such that the student or the surveyor, the participant, completely understands what they're trying to get from them. So it needs to be very clearly written. Leading questions. Those questions actually lead the participant to answer one way or another. Too many people choosing other or no opinion. And that's a question that happens often when people are really confused about the question or they're given the option. If they're not given the option to say other or no opinion, then that's another way to get out of it. And other data collection problems exist too. So following questions can be worded more effectively. We're going to describe the question's problem and what effect it could have on the results, and then we're going to prepare a more effective wording for the question. Provide both closed and open questions. The question is, I can always talk to my parents about my problems, true or false? That's kind of, there you go. Let's look at that for a second. I can always talk to my parents about my problems, true or false? Let's think about this. A closed question. My parents are available for me to answer questions, true or false? Okay, that's probably a little bit better, but I can always talk to my parents about my problems. I don't know. If your parents are a little more of a personal detail that you don't think your parents would agree with what you're doing, chances are you're not going to say yes to that or true. Maybe you can ask the question, my relationship with my parents is good so that I can approach them. My parents are very approachable when it comes to asking them questions. Or I can talk to my parents about my problems and then give them a scale, or maybe you can say something like, anyway, you get the idea. So teachers and students like the new school schedule, true or false? Okay, so now you have two different people that are in this group, and they're two different types of people. Teachers may like the schedules and students don't. Students may like the schedules and teachers don't. Students may like the fact that they have to work very little or have to go to school very often, but teachers have to be there all the time. It's a good way to look at it. So I don't think that's a good way. There's another way to ask that question. Ask the questions of teachers in a different way they ask the students. A closed question. Teachers would like this new schedule this way, and students would like this schedule this way, and give them a scale. Open, what's your opinion on the new schedule? I like the school cafeteria. Well, what do you like about it? Maybe you should be a little more elaborate about it. And so closed questions. I like pasta day on the school cafeteria. That's too closed-minded. You have to be a little more open to it, okay? The school cafeteria is clean. Maybe you could give them a list of things they can say about it. It's clean. The food is hot. It's very health oriented. The cafeteria workers are very conscientious about the students in the line. Blah blah blah. Those kind of things. And make a scale for each one of those questions. Make it a thing, and or you can make it a big opinion. Open-ended question where they can answer their whole opinion. What do you think about the school cafeteria workers and the cleanliness of this? That kind of stuff. I support school activities. What school activities? You talking about sports? You talking about academics? You talking about the chess club? You talking about drama club? You talking about what are you talking about? You have to be very specific when it comes to those kind of things, so that the person that's participating in the survey knows exactly what you're looking at. Because if you're writing this survey up to see if soccer can actually be a better sport and have more fans come to the stand, asking about school activities is probably not the right question. You need to ask specifics. All right? When designing a survey or any kind of observation instrument, a researcher must also consider how the data is collected. So here's some options. A face-to-face interview asks questions and records answers to the participants. A telephone interview asks questions and records answers. A computer calls home and records answers through key phrases or key presses. A research observer observes behavior and characteristics and marks the survey. Researcher hand delivers surveys to participants who then fill out surveys and turn it back in. Surveys mail to participants or surveys email to participants. We can see all the pros and cons to all these. Some of them are a lot more efficient for the surveyor and for the participants, but unfortunately you may not get the data you want. Pros and cons of each method. Face-to-face interview, ask questions. Well, you can actually see the people's reaction when they are asked that question, so you get more than just their answers. So you can write down, if you're writing it down or you're electronically recording their responses, you can actually see what they mean. You know what I'm saying? Telephone interview, asks questions, records the answers. You're not going to be able to see their reaction. You can kind of hear their reaction on the phone. It's one of those situations. Computer calls home, records answers through key presses. No way to see the reaction, and there's just no way to tell how the participant is actually reacting to it. So it's really, they're analyzing the data only. There's no way to analyze the participants' reactions. Researcher observes behaviors and characteristics and marks the survey. Now, this is the best way. It's also the most expensive way. So you can see there are pros and cons to each one of these. A researcher hand-delivers surveys to participants who then fill them out and return them to the researcher. It's just data collection. If they're open-ended question, we might see a little more of what they're talking about. But if they're closed-ended questions, we may not know what they mean when they say. They may not clearly understand the question, and they can't ask those questions. Mail to participants or email to participants, those are the same. They're real convenient for the surveyor and they're convenient for their participants. Now, however, there's a lot of them that if they're mailed or emailed, they won't respond to those surveys because they're required to put them in the mailbox or they're required to respond to the email. And a lot of people don't do those surveys that way. All right, so here's something. After reviewing data collected from my AQR classes this week, I've concluded that the average age of a Rudder student is 18. What do you think of my conclusion? Okay, a Rudder student. This encompasses all grades, freshman through senior. Do you think the freshman through senior have an average age of 18? Probably not. What do you think's wrong with my data that I've collected? Well, okay. Does the sample I chose represent the population I'm studying, Rudder students? No. If I'm asking my AQR students in my classes, most of them are seniors in high school. It's not a good representative sample of what the Rudder student population is like. What can be done to better represent the entire school population? Maybe send a randomized survey out to the English classes, freshman through senior, because everyone takes a English class, freshman, sophomore, junior, and senior year. So that might be a better way to represent the school population through a small sample. Recall Spud potato chips one last time. A sample was collected, had results shown below. This is a new sample. If the true mean of all Spud's bags were 28.3 grams as claimed by the company, the sample appears to have some problems. Sample mean is far below the true mean, and in fact, all the bags are below the true mean. The discrepancy between the population parameter and the sample statistic is known as statistical bias, which can result from many sources. Two broad categories of statistical bias are bias sampling method and bias statistic. Now, let's talk about this for a second. Give an example of bias sampling method. Here's a great example. Simple random sampling. How do we do that? Stratified random sampling. These are bias sampling methods. Systematic sampling, cluster sampling, convenience sampling. How are each of these given some bias? A simple random sampling is we're just going to take a number out of a hat. That could be biased because we don't know who we're going to get, and those people might actually have different opinions than the actual average opinion of the entire population. Stratified random sampling probably goes a little bit more into detail and comes closer to the population because we stratify based on the demographics of the population. And what I mean by that, say we had freshman, sophomore, junior, and senior in a high school, and we want to have some kind of ratio of the same number of students per total population of the students of each class in the sample. That would be a stratified random. So it'd be more close to the demographics. That doesn't mean it's still going to be the same opinion. Systematic sampling, that's where we find some kind of system or method to determine who's going to be in the sample group. And unfortunately, systematic sampling never finds what the average is. It just finds a group that is a sample. It's no different from simple random. It's just a different method of pulling people out of a group. Cluster sampling, that's where we take different classes or different groups of people, and we take just a couple of those groups, and we sample all of them with the survey. We survey all of them and take those as the entire sample of the population. And convenience sampling, that's the worst method ever. That's the most convenient method for a researcher to actually collect data, and he'll go out and just collect data from wherever he can get it. Go to the cafeteria and collect data from the students. It's just not a good way to find a sample of the population. All of these are prone to bias, and no matter what we do, we're going to get bias when we're doing that, when you're trying to get some kind of survey done. Sometimes researchers spend vast resources, time, money, and effort to get a great sample. I wrote that word wrong, only to end up with a biased statistic data. For example, something could be wrong with the data collection method. What could happen after selecting a sample? For example, potato chip bags, and before calculating a statistic that could result in biased statistic. All right, the scales could be inaccurate. Personal preferences took precedence, or personal precedence took precedence over accuracy, and only certain or lower responses recorded. And that happens sometimes. You get the bias of the actual researcher involved. That happens a lot. We see that in the news on a regular basis. Okay, let's keep going. If in fact the method of sampling has introduced bias, one reason for this might be that the sample was actually non-representative of the population. That's what we call a non-representative sampling. If you remember in the beginning, I started talking about statistical bias. I said, I think that the average age of a Rudder student is 18, and I got that from collecting data from my AQR classes. That's a non-representative sample of the Rudder population, is it? No, it's not. Non-representative sampling is when the sample does not represent the differences in the population. Students in a class are mainly seniors in high school, therefore they don't represent all the students in the school. If only the football team or only the volleyball team were surveyed at most schools, the sample would have all males or all females, right? Yes. All right, what other situations could be responsible for this bias? Let's provide examples where possible. All right. Undercoverage occurs when entire segments of population are missed. In the class example, freshmen, sophomores, and many juniors would be missed by my example. In a broad population, homeless people, people in prisons, people without phones, and so forth might be missed also. Several errors are possible implementing the chosen sampling method. Perhaps the strata are not identified properly. In stratified sampling, clusters were not well defined. Classes have different age groups in it, creating overlapping subsets of the population that introducing the possibility of a response being repeated. All right, biased statistics can result from variety of problems during the data collection process. Here are some ideas. We'll go through several slides like this. Why bias happens regarding each of the following sources of statistical bias. Let's look at response bias. Response bias happens when responders lie, perhaps because they have or embarrassed to give their real opinion or tell the truth, for example, regarding their past criminal record. Responders also may have a faulty memory, or they may want to impress or do not like the interviewer, so they give a lie or tell false truths, which is a lie. Non-response bias is the exact opposite, which is kind of strange. Intended participants are out of contact or just refuse to participate. In other words, they call them on the phone and they don't answer to do the survey. How about observer effect? This is when people will act differently than they normally would when they know they're a part of a study. Here's a good example of an observer effect. A football player who's at practice usually gives the coach a bunch of lip when he's out there on the field, and all of a sudden he notices that the head football coach from a big university is there, and he's watching, and his whole attitude changes towards his coach because he wants to impress him. That's what we call observer effect. Okay, observer effect is also called response bias too. It is a part of response bias. Okay. All right, wording of questions. Now, this creates a lot of bias because a lot of people, when they create their questions in their survey, the way it's worded can persuade participants to answer in a certain way. Now, think about the beginning of this lesson. We talked about a question that's asked like, all students should wear a uniform at Rudder High School. True or false? Of course, that's going to make you say no, because no one wants to wear uniforms unless it's like given a really good reason why. Okay, placebo effect. Now, this one's a cool one. Placebo is what we call it's a pill or a sugar pill that it has no effect. Part of a group that's being studied is given an actual experimental chemical or introduce some kind of drug or something, okay? Some kind of effect, some kind of food or something, okay? A treatment is what it's called. And another group is called a control group, and they're given a treatment that has no effect on them at all. It's called a placebo. And so a placebo effect is when people who are ill or in pain want a treatment to work so badly they convince themselves psychologically that it works. They're told the treatment will work and believe that it does. In other words, they're told you're going to give a treatment and it might or might not work, but they believe so strongly that they want it to work that it actually, to them, they report that it does, even though it may not. All right. So recall the second sample we collected of those potato chips, and the following results were obtained. Okay. Here's the second set. Now, the first set was all below 28. Now, this set is actually got, if you look at X bar, which is the mean of all the properties, of all of the bags we've collected, it's actually the true population mean. It's right at the true population mean. But I want you to notice how spread out it is. That comes into play. This is kind of important. What do you notice about the distribution compared to the original SPUD sample? Here's the original. Notice that it's real closed into this little area right here. But this new second sample, look how spread it out it is. And if you notice that the mean of this sample is very close to the true population mean, the data values, however, are very spread out. One bag has only 22 grams, and the other the most has 34 grams. This range is larger in this sample, a lot larger in this sample than the original sample. Okay. The sample of chips is an example of high variability and no statistical bias. Statistical bias exists when the true population mean and the mean of the data values we collect are not close to each other. Now, if you can see this, the mean, 28.32, is really close. It's only off by 2/100ths of the actual true population mean that's given by the company. So there's no statistical bias. The bias is not off at all, or the mean is not off at all. But its variability is incredible. We have a large range of about 12 grams, and that's people who get bags of 22 grams probably not really, they don't care that what the mean is. They just care that we're shorted like 6 grams of chips. Compare the standard deviations that are given for the original distribution on page 1 of this distribution. Let's take a look at it. The standard deviation for this one is 2.8, and this one is 1.4. The closer to 1 we get, the real close together it is. In other words, the data values are all really similar. Okay? The standard deviation for the second set is almost twice that of the first. This tells us the data set has a high variability. All right. So, noting the difference in the standard deviation from the first sample to the second sample, what are your recommendations for the manufacturer? Here's a good example of what we can tell them. Companies check their machinery, see if the weight of the chips can be regulated more accurately, because that's a wide range. Identify the following sample data sets as high or low statistical bias or high or low variability. Now remember, if they're all close together, that's low bias. If they're spread out, if they're all close together, it's low variability. If they're spread out, it's high variability. If the population mean is in the middle of the data set, it's low bias. But if the population mean is away from the middle of the data set, then it's considered high bias. So let's look at A. All the data values are real close together, but the population mean is nowhere near the data mean, which would be right around here, right? So guess what? High statistical bias because the population mean is nowhere near the data mean or the sample mean, and the low variability because they're all gathered together. How about this B? Population mean is nowhere near the center. That would be the center right there. So guess what? It's probably going to be high bias. The data values are very spread out, which means it's also high variability. So it's high bias and high variability. Yep. C looks just like B, except the population mean is right in the center where the sample mean is. So it's still spread out, still high variability, but the statistical bias is low. So low statistical bias and high variability. And finally, D, obviously the others are all taken, so this would be low statistical bias and low variability. Not very spread out, and the population mean is right where the sample mean is, and that's actually correct. If you wanted some way to determine exactly how these work, you need to look at these really carefully. There's another way to look at this. If you look at maybe the way people shoot at a shooting range, if you've got your gun sights shooting at a particular bullseye pattern and it's real spread out on the bullseye, but it's really the average is in the center, that's what we call high variability but low statistical bias. If all the bullets are really real centered around the bullseye and they're not very far from the bullseye, that's called low statistical bias and low variability. If they're all centered around one spot on the target, but they're not near the target bullseye, that's high statistical bias but low variability because they're all centered, they're clustered together. Now, if they're all over the place and the average is nowhere near the center of the bullseye, then that's low variability and high statistical bias and high variability. So anyway, variability can be caused by natural variability or induced variability. What does that mean? All right, so natural variability occurs when no human intervention or error. It just happens naturally. For example, temperatures vary from hour to hour, day to day, location to location. Strength varies from person to person, and grades on a given test vary from person to person, right? Natural variability. Induced variability means something is causing it to happen, okay? Induced variability. Let's take a look at this. Outside forces act to change the variability that naturally occurs. People affect the environment. That's proven to happen, which can result in causing temperatures to vary more or less or differently than before. People work out and eat differently, which affects the variation in strength, and test grades are influenced by new instructional techniques and changing study patterns. It's proven that when a student graduates from high school and moves on to higher education, their study habits change a lot. And it changes a lot because in college, the professors there, they don't take any flack from the student. If the student slacks off, their grade's going to reflect it very quickly. And a student's going to realize they're not going to be able to do the things they used to do in high school and get away with it. All right, so I'm going to launch you with this. Look at this graph. Now, this is a graph of teen pregnancies. Notice that the graph is nothing until it gets to 13 and starts to grow until it gets to 19, and then it drops off at 20. Statistics shows that teenage pregnancy drops dramatically after age 20. I'm not going to explain that. You should be able to figure that out. Anyway, have a great day. Welcome back and be blessed. Be a blessing.